Hello and welcome to this tutorial about using Triangle.net in Unity 5. Triangulation is a common task in computer graphic and can be used in game development as well, e.g. to create meshes. Triangulation is basically the generation of a net of triangles covering a surface. We see in this small example that we've got a cross that consists of a polygon, meaning different points connected to edges, that is triangulated to several triangles forming this surface. Here we see one triangle, here the other. There exist mainly two frameworks to do a triangulation. The first one is poly2tree and the second one is Triangle or triangle.net. You can find them here. Triangle.net is a conversion from the original Triangle to .net, and poly2tree exists in nearly any language out there, from Java to C# to whatever. At first I tried to implement poly2tree and use it in Unity, but I figured out that there are mainly two disadvantages. The first is optimization of the generated mesh. You cannot set minimum or maximum angles within the triangles. And the second one is hole generation. Whenever you want a hole in a triangle, you can freely design them. Holes may connect, for instance, in triangle.net, but connecting triangles are not supported in poly2tree. So that is why I've chosen triangle.net over poly2tree. The original triangle implementation can be found here, in the link below. So the agenda for this tutorial is to convert triangle.net to work with Unity 5. Triangle.net has been written for the net framework, I think version 4, which is not compatible with the Unity net framework, which is based on 3.5. In a second step, we will write a triangulation method in C#, and in a third step, we test this method we wrote to triangulate across, as we have seen in the first slide, but we add a hole to it to see how we add holes to meshes. So as mentioned before, we will make use of the triangle library, which was originally written by Jonathan Schuchak, and there's furthermore a port to .NET called triangle.net, and you can find it on triangle.codeplex.com. There are mainly two versions of triangle.net, the beta 3 and the beta 4. When you click on the download button here, you'll download the beta 3. But we want to use the beta 4 since it's it's better or easier to define holes, like we can see in this shape here. And the beta 3, it's more or less a little bit tricky. Okay, to download the beta 4, we go to downloads. Source code. And on source code we see the current source of the project, and the source code is the beta 4. We can download the entire code here, save it, go to downloads, and extract the source. So triangle.net comes as a solution for Visual Studio, and I installed Unity with the community edition of Visual Studio, so I have all libraries of Unity registered to Visual Studio. If you haven't done that, you have to do it manually. I bet it's possible, but the easiest way is to install the IDE with Unity. I open up the solution. No, I don't want version control. we see here is that the solution triangle has 3 sub-projects. The Mesh Explorer, which is basically a GUI application to inspect meshes and to generate triangulations. The second one is a triangle library that's interesting for us. And the third one is triangle.rendering, which is, I think, responsible for rendering triangles in the Mesh Explorer. Okay, as already mentioned, triangle.net has been designed for .NET 4, and we have to convert it to work with .NET 3.5. To do so, we select the project we want to convert, right-click on it, properties, and change the target framework from .NET Framework 4 to Unity 3.5 full base class libraries. Yes, we want to change it, close it, and this change results in 4 errors that you can see in the error list below here. These errors are mainly based on conversion issues between iCollections, iEnumerations, list, etc., which is not yet supported or not yet as optimized as it is in 4 in version 3.5, so we have to do it manually. We begin with the first one. Here, the method expand expects an iEnumerable, but receives a list of vertices, and we have to convert it ourselves. To do so, I select the corresponding method, press F12. Here's the right one, and we just make it compatible with list vertices. Change the name as well. Okay, save, and the first 2 errors are gone. A second error is a missing method called isNull or whitespace. We can do this check manually. If we check line for null or line trim punct dot equal dot equal an empty string. Save, and the second error is gone as well. The third one is again a conversion error that is easy to fix too. Here we add a list of segments to an existing list of segments, but again we have a compatibility error between the lists, so we add them manually. Now I have to check the type again. Type of values is topology subsegment. So for each segment, add the segment and delete the old code. Okay, that's it. Now we can rebuild the project. The build is successful, and when we go to the corresponding project binary folder, and in the debug folder we find the compiled triangle DLL. Now that we have compiled the DLL, we can create a Unity project. I call it TriangleNet. And here we import the library. Here it is. Okay, and what we have to do now is to make the library usable in Unity. And to do so, we write a simple method called triangulate that expects the common unity data types and returns the common unity data types, so that we don't have to do a conversion every time we use triangle. We create a new C# script, call it triangulate. Maybe we should pick another name. Renaming works like that. We call it triangulation. We rename the class as well to avoid collisions. Triangulation. Okay, and since this class should only contain one static method, we can delete the mono behavior and just write down this method. Public static bool. The boolean is because we want to allow a return value to say if the triangulation was successful or not. Okay, now we're missing a namespace. Okay, and the parameters we want to pass is at first a list of points, the outer points of the polygon, and furthermore we want to allow an arbitrary number of holes in our polygon. Furthermore, we have two results or result parameters. The first one are the indices of the resulting mesh. Remember, we want triangle.net have to calculate a mesh for us. And the second out parameter is a list of vertices. Okay. First thing we do is to add another namespace. Namely trianglenet geometry. This namespace contains, next to others, a class named polygon. And this polygon will hold all information about the polygon we want to create. So what we do now is to traverse all points in our list here and add those points to our polygon so that we have a nice polygon with the shape we want as a mesh as result. Furthermore, next to the points of the polygon, we will have to add segments. Segments are nothing else but edges. They connect one point to the next and form the polygon. Triangle.net requires that a polygon is closed. So we have to generate a last segment connecting the last point with the first point. We do that now. We traverse all points, and first of all we add each point to the polygon. Okay, and we add a segment as well. And if the current point we're processing is the last point in our list, we connect the last point with the first point. Oop. So if this point is the last point, we connect the last point with the first point. Oh, I'm missing a bracket here. If the current point is not the last point, we connect the current point with the following point. Okay. So what we did here is points and segments. And in a second step, we will have to add the holes to the polygon if there are any. Remember, we have a list of lists of vector 2's, so we will first have to traverse the first list of holes, and for each hole we will have to add every two-dimensional vector to the list of points for each hole. Okay, what we do here is, after we created a list of vertices for the current hole, is that we add these vertices as contour to the polygon. And here we have a second parameter which defines this contour as hole. We set it to true, and we have the hole defined. So now we can triangulate the hole. We do that by calling polygon triangulate. So this is complex. This method accepts several parameters, or yeah, you can leave it empty as well. We will leave it empty, but we can set several constraints, like we want to do conforming Delaunay triangulation, or we want to set quality options like each angle in each triangle may not be smaller, for instance 30 degrees, or not larger than, for instance, 60 degrees. Yeah, but we won't do that at the moment. At the moment, it's okay for us to receive the triangulated mesh. When that mesh is triangulated, it contains several vertices, and to construct the vertices and indices we want to return from here, we have to traverse all vertices check if they are in the out vertices list. If yes, we will set an index. If not, we'll set an index as well, but add the vertex to the out vertices list. That sounds complicated, but it is not, and we will see how to do it now. So we traverse all triangles of the mesh. And we will traverse each vertex of each triangle, and we create a variable here which is there to check if a vertex already exists in the vertex list or if it doesn't. Yeah, out vertices is not assigned. We have to create a list first. I'll do that now. Same for indices. Okay, and the error should disappear. Okay. Now we traverse all vertices we already found and check if the current vertex exists in this list. I have to check that value. Since for a reason I don't know, Unity is mixing up that and y, which is pretty annoying. Okay, we check the x value and the z value compared to the y value. And if we found one, we just add an index to the element we found. Set found to true and leave the loop. If we have never found this vertex in our list before, we have to add it. New vector 3, cast to float. Height value is 0 and last value is okay. Let me check again, but it looks right. And now we have to add an index to this new element. This index is pointing to the newly added vertex, so to the last one in the list. Last but not least, we return true. We did not process any error lists. We did not output any errors, so we just return true. But if you like, you can add errors if the exported or the triangulated mesh does not contain any vertices or indices, for instance, or if I don't know. Okay, the triangulation method is done, and we can switch back to Unity. The error we've seen before should disappear. Another annoying error remains, the line endings, which differ from Windows to Linux systems, but it should not bother us. In the third part, we create a demo to show how the triangulation method we just wrote works. In the last step, we'd like to test the triangulation method we just wrote. Therefore, we create a simple game object, call it triangulator, and for the triangulator, we need a new script. And we open that script. Okay, what this triangulator should do, it should create a game object with a cross-shaped mesh when the game starts. So we implement the start method and create a new game object. We name it cross. And so that the game object has the mesh, we need to add some components. A mesh filter. We store the mesh filter in a variable. A mesh collider. A mesh collider is not really necessary, but I want to show you some point you have to keep in mind when generating a mesh programmatically. And last but not least, we need a mesh renderer. We don't need to store that one in a variable. Okay. First, we need access to our mesh. We get it from the mesh filter. And then we can use our triangulation method on this mesh. For this method, we need a list of points, a list of holes, some returning indices, and vertices. Let's create them. No. Missing namespace. We do not need to create those two lists since they are created in the triangulate method. Okay. So last but not least, we need to fill the list of points and holes. I've prepared them here since it's too late to do it in my head. We said we want to create a cross-shaped mesh, and these are the points to do so. So I add clockwise each point to the points list as two-dimensional vector. Furthermore, I create a list of two-dimensional vectors for a new hole in the middle of the cross. And this list has to be added to the holes list. Okay, that's it. Now the triangulate method has everything it needs and can create the indices and vertices of this mesh. We received the mesh here, or stored the mesh in this variable here, and we can now assign the indices and vertices to it. We clear the existing mesh, assign the vertices, use your vertices to array method. This is called triangles in Unity, not indices. I don't know why. Yep. Furthermore, we optimize the mesh and recalculate the normals. Okay. Now speaking again about collision. We stored the mesh collider here. And when we recreate the mesh, we have to reset the mesh collider mesh. So that the mesh collider knows that there is a new mesh that collides with other game objects. Okay, I just realized I do not need the variable, I cannot use it, since I have to access the component directly. Get component mesh collider shared mesh equals mesh. Okay, so the shared mesh of the mesh collider is assigned to the mesh we just built. The reason why I don't need it is because I have to set it and not to request information from this object. Okay, in a final step we have to generate a very simple UV map. Since we have a flat surface, this one is easy. Okay, we first create an array. Nope. Okay. There are always as many UV coordinates as vertices in a mesh. And we simply assign the coordinate of the current vertex. And that's the UVs. Okay, that's it. What we do not do is to create a texture here. You can do it yourself, but yeah, I don't. Okay, what we did here is to create a new game object, to add some mesh components to it, create a list of points that we want to triangulate. These points form a polygon, a cross-shaped polygon. We define a hole in the middle of the cross, a rectangular hole because it has 4 points, and call the method triangulate. And this method returns a list of indices and vertices that we assign to our mesh. This is just 60 lines, and yeah, we can test it now. I just save the class, change back to Unity. We have the triangulator here and have to assign the script to it. Okay, now we can run our game, change to the scene view, and we see that we have a nicely triangulated cross with a hole in the middle, built as a mesh. Because it's two-dimensional, we don't see it from below, but just from above. But I think that's a fine point where you can continue working on your own and create 3D meshes or whatever you want.